Hey, 30-2. So in this lesson, we're going to be solving exponential equations, but this time we're going to be using logarithms to solve them. So we're going to be solving them algebraically or by hand, right, instead of just graphing this time. And why we're going to be doing this is it's going to be in the case where we can't write the exponents with the same base, right? So, for example, right, that was one like this where we could write it with the same base. I could have wrote this one as 3 is equal to, instead of that 9, I could have written that as 3 to the power of 2 times 2x, right? And then now I can solve, right? Because this is really like 3 to the power of 1, and then we can make our exponents equal to each other. But that rule only works when you can write them with the same base, right? So in this lesson, we're going to be solving when we can't do this, all right? So again, you guys can look through these examples. They kind of show you how to solve these things. But I think for this lesson, what I'm going to do is I'm going to jump into your guys' homework questions. All right, so question like this one. So I'm just going to write it out again. So this would be 5 to the power of x minus 2 is equal to 4. So I'm looking at this one saying, okay, you know what? I can't actually write these with the same base, right? So what's left is to use logarithms. And why are we using logarithms? Well, let's think about what the problem is. The problem right now is that the x is up in the exponent, right? Where typically if I was going to solve things using algebra, like if I had something like 2x plus 1 is equal to 4, well then you would just get everything over to one side and you just solve for x, right? But my issue is I can't solve for x because it's up in the exponent, right? How can I solve for it when it's up there? So the reason we're going to use logarithms is just to get this x down, right? We're going to just get it down to ground level. Okay? So here's what we're going to do. We are going to take the log of both sides of the equation. Okay? Now it actually doesn't matter which log we take. I'll kind of show you this question actually like 2 or maybe even 3 different ways to show you that's the same thing. So let's take just log base 10, right? So just the common log, in other words. So what I'm going to do is I'm going to write, not like that. I'll write log of 5 times, or 5 to the, and then to the power of x minus 2. Okay? And I have those brackets. You don't really need them though. You could just write it like this if you want to, but just remember you're taking the log of that. Okay, so then that's equal to, and then log base 10, so I'm not going to write anything, of 4. All right, so now that's kind of like when we take the, when we multiply both sides, like in this example, right? If we had like x over 2, if I like multiply both sides of the equation by 2, right? It's like we're just taking the log of both sides, right? So we're not actually changing anything. Okay, so why do we do that? Well, if you remember back to our log laws, one of our laws was, well, it was this one, right? Right there. Do you remember that? Where if you have a power, then you can just bring that power down to the bottom level. Okay, so we're going to utilize that, right? Because that's what we're trying to do. We want to bring the log down. So let's do that. So using that log law, now what I can do is I can bring this guy down to ground level. So now what we have is just x minus 2 in brackets, right? Because the whole thing's coming down, times log 5 is equal to log 4. And now I know this looks confusing, right? Because you guys haven't worked with logs very often, but this is just a number, right? You could put that in your calculator and you're going to get a number out of it. Okay? And this is just a number. Okay, so we're going to handle it the same way. Or like, I think it's worth probably going into this. If this expression I have right now looked more like, x minus 2 times 4 is equal to 5, would you be able to solve that one? Well, yeah, right? You would distribute the 4, and then you get x on its own, right? That's what we're going to do here too, but we're just going to have logs involved now. So we'll distribute the log 5 to both of those. So all we can do with the log 5x is just write it out as log 5x. And the next one down here is just going to be, and I'm going to write it as x times log 5. Could have been log 5 times x too, but typically we write it this way. And then then log 5 times negative 2 is going to be negative 2 log 5. Okay, and then that's equal to log 4. All right, so almost there, right? We just need to get x on its own. So again, remember, this is just a number, so we're going to handle it like it's a number, right? So what we're going to do is we're just going to add 2 log 5 to both sides. So we'll add those, so plus 2 log 5 on both sides. So now what we have left is x log 5 is equal to log 4 plus 2 log 5. Oh, and then very last step I have to do here is just, well, remember, this is just a number, right? So to get rid of it, I'm multiplying right now, so we're just going to divide both sides by log 5. So divide by log 5, and then what we're going to do, we're going to divide everything by log 5. And there you go, that's my answer. So when it says enter solution using logs if needed, this is actually what it means, right? That this is actually your answer, okay? Now, you could put that all into your calculator. And if you do, you would get x, x is approximately equal to 2.86 and then, you know, dot, 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 because this actually goes on forever, right? This is an irrational number. So this number is like pi, or taking the square root of 2 or something like that, where the numbers never repeat, okay? So we can approximate it. That's why I have like the little squiggly equal sign. That means approximately equal to 2.86. But the real answer has all of those digits all the way to infinity, right? So the best way to write your answer would actually be like this. Like you'd actually just write it in like this, and then this answer doesn't have to round any of those decimals. So this would be 100% accurate, right? And just leave it just like that as your answer. So that's what it means. Like if you need to, we need to actually leave it like that. Okay. So, all right. So that's one method. Okay. So that would be your answer. Now I'm going to show you one more with the same question. So now the other thing that we can do is, so if we write that out again, so we've got 5 times, or 5 to the power of x minus 2 is equal to 4. So now the other thing we can do is we can take the log of, with whatever base we want, right? We could take the, you know, natural log, we can take the common log, we could take log base 5, we could take log base 4. All right, so what I'm going to do this time is I am going to choose actually my base to be either 5 or 4. It'll actually work out either way. But just bear with me, I'll just kind of show you what it means. So if I take log base 5 of both sides, it has to be the same, right, on both sides. So log base 5 of 4, okay? Then watch what'll happen here. So now we'll do the same thing, right? So we'll bring the x minus 2 down, right? So now we have x minus 2 times log base 5 of 5, okay? And then that's equal to log base 5 of 4. Well, look at this. Log base 5 of 5. You can try putting that in your calculator. You'll see what you get. Remember what this is. This is saying, so if I have log base 5 of 5, this is saying 5 to the power of what is equal to 5, right? So this is log 5 to the power of 1 is equal to 5, right? So this would be 1. So in the end here, this whole thing here, that was just 1, which makes life a lot easier, because if this is just equal to 1, then it just kind of cancels out. It just goes away. So now all I have left here is just x minus 2 times 1, if you like, but that doesn't do anything. So just x minus 2 is equal to log base 5 of 4. And then what I can do now is just add 2 to both sides. So plus 2 and then plus 2. And then that looks a lot nicer, doesn't it? That's a lot cleaner. It's a lot smaller. So log base 4 or 5 of 4 plus 2 is my answer. So that's how we would type it into our box there, right? And the way that you would type these in Okay, so if you go to functions, you'll see that you guys have these different logs, and we even have log, and it shows you that you can put in a different number there, right? Okay, so yeah, we just type this in as log base 5, and then push the over arrow to go back up, of 4, and then push over, and then plus 2. There you go. Now, you might be saying, hey, wait a minute, that's a different answer than the one we had last time. Well, actually, it's not. You would end up getting the same thing, right? So if you put that into your calculator, you would get 2.8615, yada, 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 right? So that's the same approximate number. But just careful on here, because if you put in, oh, it won't let me now because I've already done it. Anyway, if I put in, this is a different number, but like 2.8, what was it, 2.86, it probably won't be accurate enough, right? So that's why it says enter using logs if needed. And it says if needed because sometimes it'll work out nicely where you'd end up with a number like 4, right? Like just exactly 4. So in that case, you wouldn't need to write it as a log, but other than that, you should be writing it as a logarithm for your final answer there. Okay? All right, let's do some more. Okay, let's do this one. Okay, so again, we're going to have to take logarithms, right? Because I can't make those into the same base. But we can take whatever type of logarithm we want, right? We could take log, right? Like our common log, or we could do the natural log, doesn't matter. Or we could do, well, log base 6 or log base 19. So here, I'm just going to write it out again. So we got 6 to the power of negative x over 13 is equal to 19. All right, so I think my life's going to be a little bit easier here if I actually just take log base 6, okay? I'll just have like less going on here. So I'll do log base 6 of both sides. So that would be log base 6 of 6 to the power of negative x over 13 is equal to log base 6 of 19. Okay, so now we get to bring this down, right? So that was the whole point. I needed to get that x out of the exponent. So now what we have is negative x over 13 times log base 6 of 6. And that's nice, right? Log base 6 of 6, we know that that's just equal to 1. Okay, so anyway, so that cancels really. It's really gone now because it's just 1 times 1. So we have left is log base 6 of 19. Okay, so this isn't too bad now. So now we've got negative x over 13 is equal to log base 6 of 19. All right, so I'll get rid of that 13. So what we'll do is we'll just multiply both sides by 13. So times 13, so those cancel. And then times 13. So we have negative x is equal to, and I'm going to write it the other way around. I'll write the 13 on the front. So it'll be 13 times log base 6 of 19. And then just to get rid of this negative on the front here, right? This is like negative 1 times x. So I'm just going to like divide by negative 1 if you like. Okay, so divide by negative 1, divide by negative 1. And then in the end here, this would all just become x is equal to 13, or negative 13 times log base 6 of 19. And there you go. There's your answer. So you can type it in just like this. Okay? Remember that to multiply on your keyboard, like if you're wondering, I don't think you'd need to. I think you can just write in negative 13 log 6 19. But if it does want this multiply symbol, remember that's shift and then the little hat, whatever that's above. I don't look at my keyboard. I'm not looking at my keyboard right now. One sec. That is shift 6. No, shift 8. Shift 8, not the little hat. The stars, my bad. So the star on your keyboard. Okay. Okay. Okay, so now let's do this one. So we've got 18 e to the x is equal to 19. So then the rule I was saying before was that we want to take the log of both sides, right? Now, which log would we take? Well, again, we can take any log we like, but you know what? There's one log in particular that's sure going to make life a lot easier. Do you remember how this e, right, that e symbol was Euler's number? And that number is, 2.718, yada, yada, yada. It goes on and on forever, right? So this is kind of like a number like pi, right? It's an irrational number. But with that Euler's number, remember the inverse of that, or like the opposite operation, is a natural log, so ln, right? So that's just what ln is, just to remind you, is just the log base e of a number, right? So instead of writing it as log base e, we just write it as ln, just lowercase l and then n. Okay, so that's the one we want, but what we're not gonna want to do this, right? We're not gonna want to go the natural log of 18 e to the x. We actually could, there's a way to make this work out where we could use our log laws to separate that out, right? Remember from before, if you're multiplying, then we could write that out now as ln of 18 plus ln of e to the x, and then we're pretty good to go. We could deal with that, right? But you know what? I know an easier way. Why don't we just right off the bat, before we get going, why don't we do this? Why don't we just kind of isolate the e to the x part, right? Just kind of get x on its own by dividing both sides by 18, right? So we'll divide by 18 and divide by 18. And now what we have left is e to the x is equal to 19 over 18. So now we're pretty good to actually just take the natural log of both sides. Okay, so we'll go natural log of e to the x and then natural log of 19 over 18. Okay, and that's like in brackets, right? It's natural log of 19 over 18. Okay, so perfect. That allows us to bring the x down. So now we've got x times the natural log of e, which, okay, we'll just keep on going though, and then is equal to the natural log of 19 over 18. All right, so the natural log of e, what could that be equal to? Well, those are like opposites of each other. You can think about those as like canceling out, right? The natural log of e, or this would be the same thing as like log base e to the e. What would that be equal to? Well, that'd be equal to 1, right? So either way, that's 1 or it cancels out. In the end here, we just have x is equal to the natural log of 19 over 18. So now if the question says round to 4 places after the decimal point, then it's okay to put this into your calculator and then just round to 4 decimal places. Okay, last one here. So on this one, so again, we'll just write it out. So we've got 1,000 times 1.06 to the power of 2t is equal to 50,000. All right, so for this one, similar idea, right? Why don't we isolate this a little bit before we get going, right? I could set this up so that we just have this part of it, right, on one side. So what I mean is I want to get rid of this 1,000, right? Because that'll make life a lot easier. It'll actually make my numbers smaller too, won't it? Because if I divide both sides by 1,000, just right off the bat, so divide by 1,000, divide by 1,000, we get, well, 50. So now what we have left is 1.06 to the power of 2t is equal to 50. So, oh, not 2t. Okay, is equal to 50. So now what are we going to do? Well, we got to take the log of both sides, right? And we can do whatever log we like. We haven't done natural logs yet, so let's do that one. So we could take the natural log, so ln of both sides, so the natural log of 1.06 to the power of 2t is equal to the natural log of 50. All right, so now that we're taking the logs, we can do our nifty little trick here. Let's bring that 2t down. So now what we have is 2t times the natural log of 1.06 is equal to the natural log of 50. And then I just want t on its own, right? So I'm just going to divide both sides by, well, we can do them one at a time if you like, or we can do them both, right? Divide by 2, divide by 2. Okay, so now we've got, I'll do them one at a time. So t times the natural log of 1.06 is equal to the natural log of 50 over 2. And then we'll divide both sides by the natural log of 1.06. So that really means when I say divide both sides, it's going to just end up in the bottom here, won't it? So the natural log of 1.06. And then that would be it. We're going, you can put it in your calculator just like this, and it does want you to put it to 4 decimal places. So that would be, yeah, 33.568 7, right? So you could just plug that in. When you put this in, right, I just want to remind you there, I should say approximately, right, because that's not actually equal to, it's just we had to round it, right? So it's almost equal to that, but it's just approximately. Okay, one thing when you put this in your calculator, if you got a different number than me, if you're doing this with me, a place that you might have made a mistake is when you actually divide it, make sure this bottom part is in brackets, right? Because if you just go log 50 divided by 2 and then times log, like if you just went log 50 and then divided by 2, and then if you go times log 1.06, it thinks you mean this, times log 1.06, right? So that's not the same thing, right? We want that down in the denominator. So just put it in brackets in the bottom, right? That should do it.